Okay, we're back again with another one of these awesome physics videos. This all being on thermals. And in this case, it's on the second worksheet. I just show it to you so you kind of know what it looks like. Problem number 1 in the solve the following problem sections. And it's this neat little equation that you're never going to use in real life. Awesome for non-real life scenarios. And you have a Concorde that is 62 meters in length. Ooh, hooray for Concorde jets. They don't exist anymore for some reason or another. On a typical day when the temperature is 18 degrees Celsius. The Concorde is primarily made of aluminum. That comes into importance later, but just so you know, it's made of aluminum. And it flies at twice the speed of sound, hooray for speed, and the friction is so warm that it increases the length by 29 centimeters. So, the question that they have, if you take into account that the coefficient of aluminum is 2.4 times 10 to the negative fifth, or for our purposes, it's just going to be 0.000024. A lot easier to think of it that way, even if it does have a lot of zeros. What is the temperature of the Concorde's skin in flight? Okay, so then what you do is, this is the original length, so it's just going to be L original. This is the change in the length, and this is the temperature original, so T. And so what we're trying to solve for is theta T. And we use the equation, that is the linear expansion equation, and it goes like this. Change in length, that is an L, that is the same as this, yeah, is equal to length original times the coefficient of the coefficient is something, I don't know. I'll have to look it up later. Sorry, guys. Coefficient, it's on the physics website. Oh, there it is. Let's see, the coefficient of linear expansion times the change in temperature, delta T. So, we know that the change in length is 29 centimeters. We know that the original length, this 6-inch aluminum, is 0.000024, and times the change in temperature, which is what we're solving for. Awesome stuff. So what we then do, multiply these two things together, and we get 29 equals, this is just basic algebra here, SL math stuff. If you're in studies, I'm sorry, you're just screwed. Times the change in T. Times the change in temperature. Then we just divide this number by this number, and we end up with 194.9 is the change in temperature. But wait, we're not quite done yet, because if you remember, the temperature was already originally 18 degrees. So we just add 18 degrees to that, and I actually haven't done this on the calculator yet, so give me a second. And you add 18 degrees, and you end up with 18 equals 212.9 degrees Celsius is the skin on the outside of the aircraft, and that's how you solve question number 1 on the second thermals and property worksheet. And just because I want to, I'm going to show you this really cool picture that I found, and it is a picture of Mr. Stickrath standing next to Miss Whitty. Mr. Stickrath, Miss Whitty. So leaving you guys with that, that's all I got. Bye.